Prior to discussing the announcement, it's important to understand what accelerators for particles are. The Large Hadron Collider, LHC, which CERN runs, is a 17-mile ring of superconducting magnets. It is the largest and most powerful particle accelerator, representing the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine, designed to unlock the secrets of the universe, lead to something far more ominous? The role of CERN. Founded in 1954, CERN is one of the world's most reputable research institutions, with 23 member states and thousands of scientists. It serves as a hub for collaboration and innovation. The LHC is CERN's flagship project, but it is just one part of a vast network of accelerators and experiments. Imagine a racetrack, not for horses or automobiles, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy levels present during the Big Bang. These collisions generate temperatures millions of times hotter than the sun's core. Thousands of magnets guide the protons along their journey, while intricate cooling systems maintain temperatures colder than outer space. At 4 locations around the LHC ring, beams are made to collide, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a unique purpose in investigating various aspects of particle physics. Together, they act as enormous cameras, capturing snapshots of these high-energy collisions. Scientists then sift through the debris, searching for elusive particles like the Higgs boson, also known as the God particle, as well as other phenomena that could reveal fundamental building blocks of the universe. By studying the microcosm, we gain insights into the macrocosm. Yet, for every question answered, a new mystery arises. The LHC, a scientific marvel or a Pandora's box? The LHC is not just a scientific instrument, it embodies human curiosity and innovation. It represents our relentless pursuit of knowledge and our desire to understand the fundamental forces shaping our universe. Yet, as we push the boundaries of discovery, we must also grapple with the moral and existential questions that arise. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash forces beyond our control? Deep within the halls of CERN, where human understanding is constantly tested, a new revelation has emerged, one that has sent a shiver down the spine of even the most seasoned scientists. Brian Cox's haunting announcement. Brian Cox, a former CERN researcher and prominent physicist, recently made an announcement that left the world both fascinated and fearful. With haunting clarity, Cox stated that the goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist elaborated on the implications of this experiment, highlighting the LHC's extraordinary potential to unlock the secrets of the Higgs boson. Explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine wielding the power to conjure the very essence of the universe itself. A tempting possibility? Certainly. A dangerous one? Undoubtedly. A past warning, the tragedy of Anatoly Bugorsky. The concept of a miniature Big Bang at the LHC is not just theoretical, it is an observable reality. The extreme temperatures, pressures, and raw energy generated in these collisions mimic the conditions of the universe's infancy. But with such power comes responsibility. And the question looms, what if something goes wrong? In fact, something did go terribly wrong once before. In 1978, Russian physicist Anatoly Bugorsky experienced a disaster that forever changed his life. While working on the U-70 high-energy synchrotron at the Institute for High-Energy Physics in Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, traveling at nearly the speed of light, entered the back of his head and exited through his nose. Bugorsky saw a flash as bright as 1,000 suns, but felt no pain. The aftermath was both horrifying and fascinating. The beam burned through his skull, destroying bone and tissue. He lost hearing in one ear and suffered partial facial paralysis. Yet, astonishingly, his intellectual abilities remained intact, and he continued his scientific career. His story is not just a personal tragedy, it is a cautionary tale, a reminder of the immense power and potential danger of particle accelerators. The risks of the LHC, could it create a black hole? The risks of a particle accelerator like the LHC should not be underestimated. One of the most alarming concerns is the possibility of creating a microscopic black hole. Black holes are regions of spacetime with such intense gravity that not even light can escape. They are cosmic vacuum cleaners, devouring stars and shaping the evolution of galaxies. The idea that the LHC could create a black hole, even a microscopic one, is shocking to both the public and scientific community. Could such a black hole grow uncontrollably? Could it swallow the Earth from within? CERN assures the public that any black hole created would be unstable, incredibly short-lived, evaporate almost instantly. Yet, the mere possibility has ignited debates, fears, and awe at the power we wield. The science behind black hole creation. To understand how the LHC could create a black hole, one must consider the mechanics of particle accelerators. When protons are smashed together at near-light speed, the energy released is so immense that it warps the fabric of spacetime. Imagine a trampoline stretched tight. If a heavy weight is dropped onto it, the fabric bends. If the weight is heavy enough, it could create a deep depression, a metaphor for how gravity bends spacetime. In the realm of quantum physics, some theories suggest that extra dimensions could exist, hidden within our reality. If these dimensions exist, then the LHC's collisions could tap into them, forming a microscopic black hole. Even Stephen Hawking himself addressed the possibility of catastrophic consequences from particle physics experiments. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels, potentially leading to vacuum decay, a cosmic event that could destabilize the entire universe. Similarly, British astrophysicist Sir Martin Rees expressed concerns that an ill-fated experiment at CERN could trigger a catastrophic phase transition, destroying the very fabric of spacetime. The final question. The stakes are unimaginably high. CERN scientists have conducted extensive safety reviews, simulations, and theoretical calculations to ensure that the LHC's operations are safe. But even with all precautions in place, we must ask ourselves, should we continue pushing the boundaries of the unknown? Or have we crossed a line that should never be crossed? The pursuit of knowledge has always come with risks. But when dealing with forces that could reshape reality itself, how much risk is too much? The LHC, gateway to another universe? Some have speculated that the LHC's experiments could open a portal to another universe or dimension. This idea, while widely dismissed by the scientific community, has captivated the imagination of many. It has become a subject of fascination, fear, and even folklore. Could the LHC be tearing holes in reality, small rifts in the fabric of space and time? Physicists working at CERN have addressed these concerns, stating that any such portal, if created, would be microscopic and momentary, vanishing in an instant. However, the theoretical possibility of such an event continues to fuel speculation. Some theories in string theory and quantum mechanics suggest that our universe might be just one of many in a vast multiverse. If this is true, then extreme energy collisions, like those at the LHC, might momentarily tap into these hidden dimensions. But what if something were to come through? What if, in our quest for understanding, we unintentionally invite the unknown into our world? The spiritual and mythological concerns. Beyond the scientific concerns, there are spiritual and mythological fears surrounding CERN and the LHC. One of the most well-known symbols associated with CERN is the statue of Lord Shiva, prominently displayed outside its headquarters. Shiva, in Hindu mythology, is the god of destruction and creation, a cosmic force that destroys worlds so that new ones may be born. To some, this symbolism is nothing more than a representation of science and transformation. To others, it is a harbinger, a sign that CERN is playing with forces beyond human comprehension. Religious scholars, conspiracy theorists, and even some scientists have speculated on whether CERN's experiments could be tapping into something far older and more mysterious than we realize. Could the LHC be resonating with energies beyond our reality? Could it be acting as a key to unlocking doors best left closed? The future of CERN and the LHC. Despite the controversies and concerns, CERN is pressing forward with its mission. Plans are already underway for future upgrades to the LHC, increasing its power and capabilities even further. Physicists hope that these enhancements will allow them to unravel the mysteries of dark matter, detect new particles beyond the standard model, understand the nature of gravity and extra dimensions. But as technology advances, so too does the weight of responsibility. The LHC is a double-edged sword, a gateway to knowledge, but also a potential Pandora's box. As we peer deeper into the universe's secrets, we must ask ourselves, are we truly prepared for what we might find? Are we opening the door to enlightenment, or to our own undoing? Only time will tell. But one thing is certain. Humanity stands on the precipice of discovery, gazing into the abyss of the unknown, and whether we take the next step wisely or recklessly may define the fate of our universe itself. Reality. Could we accidentally activate forces or entities that we do not understand? The concept of opening a door to hell has even generated sensation in a variety of media, adding fuel to the fire of uncertainty. But how did this idea come about? What does it mean in the context of scientific exploration? The parallel dimension idea is not new in physics. String theory, a major candidate for a unified theory of everything, suggests that beyond the familiar three dimensions of space and time, there are additional dimensions. It is possible that these dimensions are compressed or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now, imagine the Large Hadron Collider, LHC, as a cosmic key, unlocking sealed doors that have remained shut since the dawn of time. When protons collide at energies never before achieved on Earth, they could theoretically create ripples or vibrations that probe these hidden dimensions. If such dimensions exist, the LHC could potentially expose them. But before we get carried away with wild speculation, it's important to understand that while the LHC is incredibly powerful, there is no conclusive evidence to suggest that it will open a door to another universe, let alone hell itself. However, the allure of the unknown, combined with the mysterious nature of quantum physics, means that such ideas will continue to captivate the public imagination. Should we be concerned? Regarding the LHC and the potential risks it poses, it's easy to be swept away by sensational headlines and fears of cosmic calamity. But the truth is that researchers at CERN are well aware of the risks involved. They have taken every precaution to ensure that their experiments are safe, and they continue to monitor and evaluate their work with the utmost precision. The discoveries made at the LHC are revolutionizing our understanding of the universe, whether through the identification of new particles or the advancement of dark matter research. The LHC is not just a testament to human ingenuity, it is a window into the very heart of the cosmos. However, like any great leap forward in science, it comes with its share of risks. We must approach it with a mixture of wonder, respect, and caution. The cutting edge of scientific exploration. The Large Hadron Collider represents the cutting edge of scientific investigation, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Yet, despite rigorous safety measures and in-depth calculations, the LHC still invokes a sense of mystery and trepidation among some. The sheer scale of the machine and the energy it generates is awe-inspiring. Every new experiment ventures into uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are undeniable uncertainties. What if unforeseen phenomena emerge, challenging our comprehension of physics and the laws of the universe? The LHC pushes the limits of human understanding and forces us to question the extent of our control over the natural world. As particles collide and recreate conditions not seen since the Big Bang, we must consider the potential consequences of manipulating the very fabric of the universe. The balance between discovery and risk. Nevertheless, the LHC's achievements in particle physics have been transformative. It led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened new opportunities for future developments that could reshape our technological future. Despite the risks, the quest for knowledge continues to be one of humanity's most ambitious endeavors. Scientific discovery is rarely without risk, and the LHC is no exception. Its operations delve into realms of physics where intuition no longer applies. For decades, physicists have sought to understand the four fundamental forces of nature. 1. Gravity. 2. Electromagnetism. 3. The weak nuclear force. 4. The strong nuclear force. Each of these forces plays a crucial role in shaping the universe. The LHC has been instrumental in providing clues that bring us closer to a unified theory of everything, where all these forces might be reconciled under a single framework. As humanity continues to explore these frontiers, the very nature of these experiments raises important ethical considerations. Could advancements in particle physics lead to unintended consequences, not just for our planet, but for reality itself? These are not easy questions to answer, and they require careful thought about the broader implications of scientific progress. For example, the creation of exotic particles or the exploration of high-energy conditions could reveal unknown aspects of the universe. But they also carry the risk of triggering new phenomena that are difficult to predict. The pursuit of knowledge in these uncharted areas inspires both excitement and fear. The responsibility of scientific exploration. Some argue that our understanding of quantum physics is still in its early stages. The LHC, which operates in the realm of subatomic particles, may one day lead to unforeseen discoveries with far-reaching consequences. In the end, the LHC's experiments are designed to shed light on some of the most profound questions in physics. Yet, they also force us to confront a crucial aspect of human nature, the desire to push the boundaries of the known, often without fully grasping the potential consequences of that exploration. The hope is that the LHC's discoveries will lead to a deeper understanding of the universe. But as we venture further into the unknown, uncertainty will always remain. As the LHC continues its groundbreaking work, it also serves as a reminder of the interdependence between scientific discovery and societal responsibility. CERN's experiments may one day revolutionize fields beyond physics, such as energy generation, material science, medicine. By studying particles and their interactions, scientists may unlock new methods for harnessing energy or even discover novel forms of matter that could transform technology as we know it. However, the potential for both extraordinary progress and unforeseen difficulties always exists. The delicate balance between exploring the unknown and managing risks requires vigilance. As humanity looks to the future, it is crucial that we navigate this path thoughtfully, ensuring that we approach the wonders of the universe with both respect and humility for the unknown consequences of our actions. The search for the ultimate truth. The Large Hadron Collider, LHC, is more than just a machine. It is a symbol of humanity's relentless pursuit of truth. It represents our desire to uncover the hidden laws governing the universe, to seek answers to fundamental questions that have puzzled scientists and philosophers for centuries. What is the true nature of reality? Are there hidden dimensions beyond our perception? Could our universe be just one of many in a vast multiverse? These are not just theoretical questions, they are at the core of modern physics. The LHC's experiments are designed to probe these mysteries, pushing the boundaries of what we know and revealing new layers of the cosmic puzzle. One of the most intriguing ideas explored by theoretical physicists is the multiverse theory, the notion that our universe is just one of countless others, each with its own laws of physics, possibly branching off from one another like an endless cosmic tree. If the LHC were to discover evidence of extra dimensions or interactions that hint at parallel universes, it would revolutionize our understanding of existence. But such revelations could also come with profound philosophical and existential implications. The ethical dilemmas of scientific progress. As we venture deeper into the unknown, we must confront the ethical questions that come with such advancements. The history of science has shown that progress often comes at a cost. From the development of atomic energy to the rise of artificial intelligence, groundbreaking discoveries have led to both unimaginable benefits and unforeseen dangers. The LHC is no exception. While its mission is to expand our understanding of the subatomic world, some fear that unlocking new knowledge could have consequences beyond our control. What if, in our quest for answers, we inadvertently unleash forces we do not understand? Could we stumble upon new states of matter that destabilize the universe as we know it? What if our reality is more fragile than we assume, and our experiments have deeper repercussions than anticipated? While these concerns may sound like science fiction, history has shown that paradigm shifts in science often come with unexpected consequences. This is why researchers at CERN exercise extreme caution, conducting thorough risk assessments before embarking on any new experiment. Beyond the standard model. One of the most exciting aspects of LHC research is its potential to go beyond the standard model of particle physics, a framework that, while successful, leaves many questions unanswered. For example, the Higgs boson, discovered in 2012, confirmed a key aspect of the standard model by explaining how particles acquire mass. Yet, this discovery was just the beginning. There are many unresolved mysteries in physics. What is dark matter, the invisible substance that makes up most of the universe's mass? What is dark energy, the force driving the universe's accelerated expansion? Why is there more matter than antimatter, allowing our universe to exist in the first place? The LHC may hold the key to these mysteries, offering insights that could reshape our understanding of the fundamental forces that govern everything. The future of particle physics. Looking ahead, scientists are already envisioning the next generation of particle accelerators. The LHC is a technological marvel, but future projects, such as the proposed Future Circular Collider, FCC, could reach even higher energy levels, probing even deeper into the nature of reality. These advancements raise an important question: how far should we go in our pursuit of knowledge? There is no doubt that science has the power to transform our world in unimaginable ways. It has allowed us to harness the power of atoms, map the human genome, and explore the depths of space. But with great power comes great responsibility. A journey without end. The LHC is not just a machine, it is a gateway to the unknown. Every experiment conducted within its massive tunnels brings us closer to deciphering the secrets of the cosmos. Yet, the more we learn, the more we realize how much remains undiscovered. Perhaps the greatest lesson of all is that the universe is far more mysterious than we ever imagined. As we stand at the frontier of scientific discovery, one thing is certain: the journey of understanding is far from over. Whether we uncover parallel dimensions, new particles, or deeper truths about reality itself, the quest for knowledge will continue to define the very essence of human curiosity. What lies beyond the horizon? Only time, and science, will tell.